Hello everyone. Today I am going to teach you ASTABLE multivibrator practicals using 555. The aim of this practical is to construct an ASTABLE multivibrator using IC 555 and to measure the time period and frequency of the output. The requirements are IC 555 timer, capacitors, resistors, 12-volt power supply, CRO, etc. Formula for this practical is to find frequency from calculation 1 by 0.693 RA plus 2 RB into C hertz. From observation, that is from the output waveform 1 by T1 plus T2 hertz. For duty cycle, from calculation RB by RA plus 2 RB, from observation T2 by T1 plus T2. Formula expansion, RA, RB resistances, C capacitance in farad, T1 on time in seconds, that is state 1, T2 off time in seconds, that is state 2. Let us see the pin diagram for IC 555. First pin ground, second pin trigger, third pin output, fourth one reset, fifth one controlled voltage, sixth threshold, 7 discharge, 8 plus VCC. The circuit diagram for this practical is like this. Number 1 ground, number 8 plus VCC. Here in between terminal 1 and 2, one capacitor is connected. And grounded here. 2 and 6, terminal 2 and 6 are tied up and connected with the other end of this capacitor. Then in between 6 and 7, resistance RB is connected. In between 7 and 4, resistance RA is connected. RA and RB may be of 1K, 10K, etc. 8 and 4, terminal 8 and 4 are joined together and connected with plus VCC. Terminal 3 output with respect to ground. Then in terminal 5, there is one capacitance is connected, 0.01 microfarad. Other end of the capacitor is connected with the first terminal of IC 555. So the output for this practical will be like this. Output pulse. It will be like a square wave. So on stage is otherwise called as state 1, off state 2, on, off, or high, low, or digital 0, 1, etc. X-axis time, Y-axis indicates output voltage. Procedure. Connections are made as shown. Initially, the voltage across the capacitor is 0 and the output is high. When the capacitor starts charging through resistor RA and RB, when the voltage across the capacitor crosses 2 by 3 VCC, the output voltage goes low. First, when C is equal to 0, output high. When the capacitor starts charging, the output voltage goes low. Now, capacitor starts charging through RB only. When its voltage goes below 1 by 3 VCC, output once again goes high. The charging and discharging is repeated and square waves are obtained. Output is observed using a CRO. So observation, that is the table we have to fill. RA, RB, maybe of 1K, 10K, etc. C in microfarad, 0.01, 0.02, 0.03 microfarads, etc. T1, T2, we have to measure from the output waveform. Then you have to calculate the frequency and duty cycle using the very same formula from calculations and from observations. Duty cycle calculation is in percentage. The result for this practical is the ASTABLE multivibrator is constructed using IC 555 and its performance is studied. By varying the value of C, the time period and frequency of the waveform are measured Now I am going to show you how to create our circuit using www.tinkercad.com. Enter. A page will open like this. Click circuits, then create new circuit. So first let me search breadboard. Breadboard small. Okay. Next, for this circuit, we need instruments like one power supply. Click and drag. Power supply of 12 volts. Then CRO oscilloscope. Let us change the time per division as 1 milliseconds. Okay. Then search IC 555. Click, drag, fit it like this. Okay. Now search resistor. Select one resistor. Move, rotate, rotate, rotate. Fit it here. Okay. The value of this resistance is 1K. 1 kilo ohm. Another resistance we need is rotate, rotate, rotate. Fit like this. The second resistance value is 100 kilo ohms. You can see the color changes here. Okay. Now the other component needed is capacitor of value 0.01 microfarad. 0.1 microfarad. Okay. Move and fit it here. One more capacitor also we require. That is also of same value. 0.01 microfarad. Okay. Now let us connect. Move, move. Power supply to breadboard. The whole row can act as positive terminal. Positive. So let me select red color. Okay. Then negative to negative. Change the color of this wire as black. Negative connection, ground connection. Let us connect the oscilloscope's negative terminal also to the negative end. Change the color of the wire as black. Then third terminal is the output. Let us change the color of the wire as yellow. Okay. Now, eighth pin to plus VCC, red color. Then fourth pin to plus VCC, again red color. Okay. Fourth pin, eighth pin are connected with plus VCC, right? Second pin and sixth terminal are to be connected. Blue color wire. Then first pin to ground, ground, black color. Okay. 1K connected in between 7th terminal and 8th terminal. So one end of 1K to 8th terminal. Orange color wire. Other end of 1K with 7th terminal. Orange color wire. Okay. Now 100K is to be connected between 7th terminal and 6th terminal. 7 to one end of 100K. Okay. Then again 6 to other end of 100K. Right. In between 1 and 5, we have to connect one capacitor 0.01 microfarad. So first terminal grounded, one end of the capacitance is to be connected with terminal 1. Okay. Then the other end is to be connected with number 5. Let me delete this. Once again, let us try. Let the color be purple. Okay. So the capacitance in between 1 and 5 is connected. Next, another capacitor is to be connected with connector to be connected in between 1 and 2. Let me shift this capacitor here for my convenience. One leg to be connected with ground, black color wire. Okay. Second terminal to the other leg. Some other color wire. Okay. Hope connections are complete. Let us check and start simulate. Yes, it is working. We get the output waveform here for 0.01 microfarad. This capacitor is a variable capacitor. So let us change the value for this capacitance as 0.02 microfarad. Okay. Start simulation. Now you can see the time per divisions vary. On state, off state varies. Stop simulation. Change the value for the variable capacitor as 0.03 microfarad. Start simulation. Now some other value for T1, T2. Stop simulation. Again 0.04 microfarad. Start simulation. You can see the time, varying length of the time per divisions. That is the on state and off state of T1, T2. Measure. Note everything in the observation table. Calculate as per the formula. And you will get your result. Here we select the oscilloscope as time per division of oscilloscope as 1 millisecond. We can also change as 10 millisecond. See the changes here. So thus we can vary and measure. In our regular practicals, we will trace out this output. So here you can take screenshot, crop and share it to your teacher if required. Hope you enjoy this practicals. Try once again. Check each and every connections. And definitely you will get the result. Thank you.